Welcome to the Math Record. Today we'll be answering the CCML Algebra 2 Contest 1 2016-2017 Division A. Okay, let's get started. Question 1. Solve for x. 2x minus 5 is equal to 11x minus 2x. So just add 2x to both sides, get 4x. Add 5 to both sides, get 16. So x is equal to 4. Okay, that's the first question. It's basically that easy. Just 4. Just rewrite your variables. 2, solve for y. X is equal to 2y plus 3x. So minus 3x from both sides, get negative 2x is equal to 2y. Divide by 2, so you get negative x is equal to y. So y is equal to negative x. That's your answer. Sometimes answers are just not definitive, like a definite answer is like 1, 2, 3 or something like that. So it's like probably a negative x. Since these are only with variables, the answer is only with the variable. Solve for coordinates x, y. 2x plus x plus 2y is equal to 3, and x plus 3y is equal to 5. So multiply the first equation by -1. Second equation, x plus 3y is equal to 5, and then add together. So y is equal to sorry, that's -3. Is equal to 2. So plug in 2 is here, so x plus 6 is equal to 5. So x is equal to -1. So the answer is just -1, 2. Okay. Question 4. A right triangle has two angles of ratio 1 and 2. If x represents the measure of the largest angle in the triangle, determine all values of x. So let's draw a picture. So since it's a right triangle, right, one of the angles is already 90, and we have two angles right here, x, y. So it says 1 to 2 ratio. So technically, 90 is the biggest, right? So technically, you can't have the ratio like this, 2 to 1, because that doesn't make sense. Because it has to be great. If this is greater than 90, then it's not going to be a triangle. So for it to be a triangle, either it's going to be ratio 1 to 2 here, or vice versa, 2 1, or it's going to be 2 to 1 here, or 2 to 1 here. So technically, it's just so we have 3x to get 90 degrees. So let's say x plus y is equal to 90 degrees, right? So you have 3x, so x is equal to 30. So I'm not saying x is this equals this x. I'm saying x is the variable here. Let's just use a, because I don't want to confuse you. A is equal to 90, and a is equal to 30. So a is equal to x, because so it's 30, and the other one is equal to so this one's equal to a, and this one's 2a. So that's why I didn't want to confuse you with the x. So that would be 60. So that's a 30, 60, 90 triangle. So that works because that's a 1 to 2 ratio. And now if it's like this to this, since this is already 90 and this is a 1 to 2 ratio, then technically this would be 45. So this will also be 45. So there'd be 45, 45, 90. So the two smallest is 30 and 45. And that's your answer. It's 30 degrees and 45 degrees. Okay. Question 5. If the slope of a line that's perpendicular, give the slope of a line that's perpendicular to a line determined by 5x minus 3y plus 10 is equal to 0. So technically, you just minus 5x from both sides and then divide by -3. So -5 divided by -3 is 5 over 3. So that's our original slope. So to get the perpendicular slope, you just negative and reciprocal. So -3 over 5. That's our answer. Basically that simple. Question 6. The shaded region shown to the right is a spherical lane. If the portion of the sphere in between the two semicircles of the sphere that meet at the north and south pole, if the acute angle between the semicircles is 30 degrees, what fraction of the sphere's area is contained in the lune? Okay, surface area is just like 4 pi radius squared, right? For a sphere. Since you know that since this is radius squared, this what tells me is that it's in the second dimension. Since this is in the second dimension, it's gotta be out of 360 degrees. Like just think about it. Since this is if it's out of the third dimension, has to do with volume, it's not gonna be 360 degrees because it's gonna be a little weird. So it might not be out of 360 since it's in the second dimension. We know for sure it's 360 degrees. So since this is 30 degrees, right? If we draw like the sphere or how it looks, right? And it looks like this, right? And this thing is 30 degrees out of 360, then technically we have just 30 out of 360. So the portion is just 1/12 if you simplify it. Another way to think about it is that you see this spherical circle, I mean sphere, circle. You kind of cut it in half around that dotted like circle, and then if you like squish it down to a 2 dimension, technically you're just gonna get a circle, right? And it's just like that, and it's 30 degrees. And then you have another circle for that bottom portion, which is 30 degrees. So technically, to combine together, you get 60 degrees, right? 30 plus 30. And then the entire thing is 360, and this is also 360, which is 720. So overall, this is also just 1/12. See, that's another way to think about it. Number 7. The line containing a plus 1, 5, and 2a, a plus 1 has a slope of 4. Determine the value of a. So it has a plus 1 minus 5 over 2a minus a plus 1 is equal to 4. So a minus 4 over a minus 1 is equal to 4. So a minus 4 over 4a minus 4. So a just has to be equal to 0. That's that's basically what the answer is. Because if you add 4 to both sides, just a is equal to 4a. And the only way for it to be like the same is if a is equal to 0. So that's the answer. A is equal to 0. Okay. Question 8. A sphere with the radius of r is full of water. How many right circular cones with base radius r and height r can be filled with the water from the sphere? So, the volume, the surface area of a sphere is 4 pi, um, I mean, yeah, the volume of a sphere is just 4/3 pi radius cubed, and the volume of a cone is 1/3 pi radius squared times height. Since the height is also r, it's just r cubed. So 4/3 pi radius cubed divided by 1/3 pi radius cubed is just 4. So the answer is just 4. Okay. Question 9. Compute the area of a polygon whose vertices in cyclic order are 2, 2, 2, 4, 8, 6, 10, 4, and 8, 2. Okay, the first thing you want to do is that you want to make a picture. So you have 2, 2, 2, 4, 8, 6, 10, 4, and then 8, 2. So something like this, right? So what you're going to be using is something called the Shoelace Theorem. It gets you the area under a like of a polygon in the Cartesian plane. So just use a bunch of matrices. So what you do is that you look for the rightmost point, which is right here, this point right here, and that is 10 comma 4. And then you write and then you go counterclockwise. So the next point is 8, 6, and then 2, 4, then 2, 2, right? 2, 4, 2, 2, and then you write 8, 2, and then you go back to the first point, which is 10, 4. Okay? So what you do, let me move this. Sorry, you're not going to see the picture. We don't need the picture anymore. Okay. Oops. Okay. What we're going to do is that we're going to use matrices for every single 2. So 10 times 6 is 60. 8 times 4 is 32, so you minus 32. 8 times 4 is 32. And then 6 times 2 is minus 12. And then 2 times 2 is 4. And then 2 times 4 is 8, so you minus 8. And 2 times 2 is 4. 8 times 2 is 16. 8 times 4 is 32. And 2 times 10 is 20. So what I do here is I cross out any numbers that kind of like already cross these numbers out. So negative 32, then negative 32, negative 12, and negative 20 cross out this 32. These bubble 4s minus the 8. So it's just left with 60 and negative 16. So add those together, you get 44. And whatever is remaining, multiply by 1/2, and you get the answer, which is just 22. So the area of that polygon is just 22. Okay. Question 10. T is the trisection point of AB that's closest to A, and T has coordinates -1, 6. If point A has coordinates negative 3, 5, find the coordinates of B. Okay, so let's just put the coordinate of A first, which is negative 3, 5. So just put it right here. It doesn't matter. Who cares? You really don't need to like draw a complete graph. So you have negative 3, 5. And you also give the coordinate of T, which is negative 1, 6. And T is closer, it's a trisection point of AB that's closer to A. So it's closer to A. So we have a point negative 1, so it's going to go to the right, and then 6. So it's going to go something here. So it's like negative 1, 6, right? So it's a trisection point. So it's going to go something like this. So it's got to be a point here, point here, point here, and point here. Right? So technically, right here, you have to go, you have this A and this B. So you just have to go up like 3 triangles. So you move up 1 up and then 2 to the right. So move 1, move 2, move 1, move 2. So from T, you just add 4 to the X, which is just 3, and 2 to the Y, which is just 8. So it's just the point of B is just 3, 8. So you basically just make a picture. It's easier and it's the most efficient. So the answer is 3, 8 if you didn't hear. Okay, question 10. When written in base B, the natural number n has units digit of 1. If n is even and 2 to the power k divides b with a 0 remainder, what's the maximum value of k? Okay, so the first thing is that n is even. So this even tells me that when we're working with bases, we should consider the possibilities of odds and evens. So when written in base B, the natural number n has units digit of 1. Okay, so base B is either even or odd. So odd or it's even. Okay. When written in base B, the natural number n has a unit digit of 1. So when n, which is even, written in base B, it becomes odd because it has unit digit of 1. So if it's 1, it's odd, okay? So technically, since it turns to odd and n was even because of base B, then B has to be odd. Because B can't be even. Because let me give you an example. Let's say we have a variable x, y, z, 1, right? So like x, y, z is just placeholders for like the numbers, units, digits. So let's say the number was like 3,221 or something like that, you know? So basically, in base B, to convert base B to n, which is in base 10, you just gotta have 1 plus b times z plus b squared times y plus b cubed times x. You see how that works? Because it's the 0th place, 1st place, 2nd place, 3rd place. So, you know, 3rd place, b squared x. 2nd place, b squared y. 1st place, b times z. So if b is even, right, then anything multiplied by an even is just even. Even if it's odd or even. So all these are even, add by that one is odd, which doesn't make sense because then if this is all odd and n is even, that's not the same number. So it cannot be even. B cannot be even. So B has to be odd. That's what it's telling me. Okay? So if B is odd, then let's go on the second part. If n is even and 2k divides b with 0 remainder, so b is divided by 2 to the power of k, it has a remainder of 0, right? So b is odd, as I told you. The only way for an odd to have no remainder if it's divided by another odd. Because it's odd divided by even, it's going to have a remainder of like 1 left over. 1 or like some kind of like odd number. So the only way for it to be a 0 left over is that it's some kind of odd divided by an odd. It doesn't work all the time, but sometimes it works. So it's like 3 divided by like 5, or like 9 divided by 3, which is a better example. So it leaves like no remainders, right? It's or because if you have something like this, which is just 3 divided by 2, it has a remainder of 1. So you can't have that. So you have to have the odd divided by odd. So the only way, since b is odd, right? Then 2 to the power k has to be odd. And the only way for 2 to the power k to be odd if it's 2 to the power of 0, which is equal to 1, because 1 is odd. So the only answer for k is 0. So this question is a little bit of logic, basically. Question 12. A triangle has side lengths 15, 15, and c, where c is a whole number. Give the arithmetic mean of all possible values of c. For a triangle to actually be a triangle, like the two smallest side lengths adds up together has to be bigger than the third side length. So technically, it's just c 15, 15, 15C, 15, and 15, 15C. So like C is between 15 and C is less than the 15s and C is greater than the 15s. So technically C plus 15 has to be greater than 15. That's what it says for the first one. And C plus 15 is greater than 15, so we don't have to write that again because we already wrote that. And 15 plus 15 is greater than C, so that's just 30 is greater than C. So C has to be greater than 0 and less than 30, basically. That's what it's telling us. So C has to be between 1 and 29. So that's what it states. C is from 1 to 29, and it has to be a natural number. So it's like 1, 2, 3, 4, etc. Because it says whole number. I mean whole number. So it can't be 0 and it can't be 30. So because it's from 0 to 30, and it says 1, so it's 1 to 29. So the arithmetic mean of all possible numbers. First we need to get the sum of this and then divide by the number. So basically the sum is just the number of terms, which is 29, divided by 2, and the first term, which is 1, and the last term is 29. So it's 29 times divided by 2 plus 1 plus 29. So that's 30 divided by 2 times 29, and we get 435. And the arithmetic mean is just 435, the sum divided by the amount of term, which is 29, which equals to 15. So the answer is 15. A faster way to do this, instead of doing all this math, is that you see 1 and 29. The arithmetic mean is just the whatever the first number plus the last number divided by 2. So technically it's just 1 plus 29, which is 30, divided by 2 is 15. Because like, look at this, it's just 29 divided by 2 and 1 plus 29. And that gets 435. So you have to divide by 29, you just put 29 right here, which cancels out this 29. So it's just 1 plus 29 divided by 2. So mathematically, it makes sense. So it's just the last term plus the first term, and then divide by 2. Okay. Question 13. Matt loves to do back squats in his CrossFit workouts. At a certain point during the set, he has completed 1/4 of the total amount of sets. After 5 more back squats, he completed 1/3 of the total. How many total back squats are in the set? So let's say X is the total amount of back squats. So 1/4 of X, right? Plus after 5 more, he is doing 1/3. So just solve for X. So 1/3 minus 1/4 is 1/12 equals 5. So both divide by 12 to both sides. So 60 is equal to X. So the total amount of back squats is 60. Okay. Question 14. If 1 divided by p plus 1 is equal to 1, p minus 1 over p squared minus 1, what values of p are impossible? So 1 divided by p plus 1 over, minus p minus 1 over p squared minus 1 could be distributed out to p minus 1 times p plus 1. So that kind of crosses these out. So technically, you just have 1 over, which is the same thing. 1 over p plus 1 is equals 1 over p plus 1. So all possible p's are possible. So the only way for p to be impossible would be is p is p makes one of the equations undefined. So right here for the left side, p is undefined when p is equal to -1, and for the right side, p is not possible if p is equal to plus or minus 1. Even if you look at the factor equation for our right side, p minus 1 divided by p minus 1 kind of gets to out. It's either it's undefined when it's either an asymptote or it's a whole. So when p is 1, that makes it asymptote. When p is when p is 1, it's equal a whole, and when p is -1 is equals an asymptote. There's -1 here, that makes 1 over 0. But if p is 1 here, then the 1 kind of cancels out. But it's still there because it's undefined. It's something that you kind of learn in pre-calculus. So the answer is plus or minus 1. Okay. Question 15. How many integers from 1 to 1,000 are multiples of 3, 6, or 10? So 1,000, this is inclusive, divided by since we have multiples of 3, 6, or 10, we don't really have to do 6, because if it's a multiple of 3, right, then it's, you just think about this example. You have 3, 6, sorry, I wrote 9. 3, 6, 9, 12, 15, 18, right? And you have like 6, 12, 18. And since it's 3, 6, or 10, right? So it's it could be any of these and any of these, or like any of the 10s. I'm not gonna write those out. But basically, so um you already have the 6 is already recorded here, right? And the 12 is already recorded, and 18 is already recorded. So the only things we have to look for are multiples of 3. But if it's a multiple of 3, you're already gonna get all the multiples of those 6s, basically. So that you don't. So the only ones you have to look out for is the multiples of 3s and the multiples of 10. So 1,000 divided by 3, there's 331 of those, 333 of those numbers. And 1,000 divided by 10, you have 100 of those numbers. But you gotta think about it, because like some numbers of 3 and 10 can overlap, like 30, which is divisible by 3 and divisible by 10. So you gotta have like 1,000 divided by the least common multiple of 3 and 10, which is 30, which is equal to 33. So you add these together and you subtract this, because these are like recorded twice, because like 3 can have 30, 10 can have 30, which is added both at the same time. So like 30 is in both 333 and 100, or like 60 or like 90 and stuff like that. So technically you just add them together. So that's 433 minus 33 is 400. Since the integer stays from 0 to 1,000 inclusive, that means 0 is also included, so you gotta add 0. 0 is also a multiple of like any number, so it's just 401. So the answer is 401. Okay. 16. Solve for x, y, z. Y is equal to x. X plus 4, z is equal to 7, and negative x minus 2z is equal to negative 3. So let's just focus on the last two equations. You add them together, so you get 2z is equal to 4. So z is equal to 2. Since z is equal to 2, the first equation tells us that y is also equal to 2. So you have 2 and 2, right? So you plug in z is equal to 2 on the second equation, you get 8. So x plus 8 is equal to 7. So x is equal to negative 1. So the answer is just negative 1, 2, 2. Really just that simple. Okay. Question 17. If a divided by b is equal to a plus c over b plus d equals to 3, 4, compute the value of a divided by a minus c divided by b minus d, given that b is not equal to d. Okay. So a divided by b is equal to a plus c over b plus d. Multiply them out, so you get AB plus AD is equal to AB plus BC. AB here is recorded twice, so cancel those out. So you get AD is equal to BC, right? So if you divide, let's just get something into the denominator. So you have A, and let's just get C. Okay, since this is BD in the denominator, I should probably just put those in denominator. So divide by B and divide by D. So technically you have A divided by B is equal to C divided by D, right? So that's what it tells us. So I guess we could like substitute these variables in. Actually, we have 3/4. So let's work with the 3/4. Let me cancel all these out. So you remember AB equals, actually I'll just write that down again. Okay. AB is equal to C over D. And AB is 3/4, right? That's what we have already. Then BCD is also equal to 3/4. That's what it's telling us, basically. So okay. That means A minus C over B minus D. So actually, let's just do it another way. So A divided by B is equal to 3/4. So that's 4A is equal to 3B. and you have a plus c divided by b plus d. So we have 4a plus 4c. So for the second and third one, basically, is equal to 3b plus 3d. So substitute the 3b in for 4a, so that makes 4a. So this thing cancels out with this one technically. So 4 4/3 of c is equal to d. So that's what it states. So a minus c. Let's substitute that back in. So b is equal to 4/3 of a, right? And d is equal to 4/3 of c. Oh, see? Now you have something, basically. Because you could just sorry, that's a C. Now you could just distribute the 4/3 out, right? So then it's just A minus C cancel each other's out. So it's 1 over 4 over 4/3. So the answer is just 3/4. So the answer is 3/4 for 17. Just some variable manipulation. 18. A unary operation is a function whose input and output are both singular numbers. For example, squaring is a unary operation. Suppose that the set of elements is closed under a unary operation, meaning that the inputs and outputs must both be elements of the set. How many unary operations are possible? Okay, so let's well, it's kind of like a more of a memorizing question because this is a really cool thing. So if it's a unit operation, the total amount of operation is just x to the power of x. And if it's like binary, it's just x to the power 2, unary 1. And then if it's ternary, which is 3, x to the power 3. So you just gotta think about it. So it's not think about it. It's just more about memorizing. So the answer is just x to the power of x. But since they said it was in variable n, it's just n to the power of n, basically. So that's the answer, n to the power of n. One way to think about it is like every single output has n inputs. So since you have n inputs, right, and you have n every single output, what you do is like is n has n outputs. Well, the first input has every single n output, right? And the second input has n every output, and the third has n, fourth has every single n, and then basically as you go up to nth, you have n power. So how many like outputs are there basically? So we have 1 with n, 2 with n, 3 with n, 4 with n, so n to n. So it's just 1. So you have n here, you have n amount here, n amount here, n amount here, n amount here. So technically as you go to nth, you see the pattern. It's just you just go n to the power of n. So as you like go out with it. So that's basically how it like works. So it's a pretty cool idea to think about, but they did give you enough information. But that's basically what it is. It's just n to the n, and now you know. So n to n is unary, n to n to the power 2 is binary, ternary, n to n to 3. Solve for y. X is equal to 2y plus 8 over x minus y. So multiply x minus y to both sides to get x squared minus xy is equal to 2y plus x. Isolate y to both sides, so x squared minus x is equal to 2y plus xy. So you have x squared minus x. Distribute out the y to get x plus 2, and then x plus 2 is equal to y, basically. So this is your answer, x squared minus x over x plus 2. Just rewriting variables, basically. Question 20. Determine the largest value of k such that 1 plus 1/2 of x plus k is greater than or equal to 10 has only non-negative solutions for x. K is only non-negative. So non-negative solutions for x means 0 to like any positive number. So technically the solution set is 0 to infinity. So so plug in x is equal to 0 and you get 0 plus k, so k is just be greater than or equal to 10. And you plug in infinity. Infinity is just a really big number. So infinity plus k is just like a big positive. And a big positive is greater than 10. So infinity works. So k just has to be greater than or equal to 10. So it's just gonna be 10, right? I mean, has only non-negative solution because that's the largest value of k, you know? So that's basically the answer. I mean, I don't know how else to explain it. It's basically just that simple. K is greater than or equal to 10, so you just put 10, you know? Because you can't go less than it. Because if you go less than it, like, you put, uh, 9, right? Then you could put in, like, um, I mean, not 9. If you put in, like, 11, right? Then x could be, like, -2. And -2 is negative, plug in -1 plus 11 is 10, and 10 is greater than or equal to 10. So -1 is the solution set, but it says not negative. So you can't have something like that, so 10 is the biggest possible number. Right here, you could just also start testing points anyway. So if you get k is greater than or equal to 10, you just test like number 9, number 10, and see like if there's possible negatives. That's way to just check your answer. But it's basically simple. It's just 10. So that covers the CCML Algebra 2 Contest 1 2016-2017 Division A. Thanks for watching, and I'll see you at the next math record.